Section 5.2, Power Functions and Polynomial Functions. Suppose that a certain species of birds thrives on a small island. Its population over the last few years is shown in Table 1. In the year 2009, the bird population was 800. In 2010, a year later, it's now up to 897. 2011, 992, 2012, 1083, 2013, 1169. Now, the population can be estimated using the function p of t, which is equal to negative 0.3 t cubed plus 97t plus 800, where p of t represents the bird population on the island t years after 2009. We can use this model to estimate the maximum bird population and when it will occur. We can also use this model to predict when the bird population will disappear from the island. In this section, we will examine functions that we can use to estimate and predict these types of changes. Identifying power functions. Before we can understand the bird problem, it will be helpful to understand a different type of function. A power function is a function with a single term that is the product of a real number, a coefficient, and a variable raised to a fixed real number. A number that multiplies a variable raised to an exponent is known as a coefficient. Now, as an example, consider functions for area or volume. The function for the area of a circle with radius r is a of r, which is equal to pi r squared. And the function for the volume of a sphere with radius r is v of r, which is equal to 4 over 3 times pi times r cubed. Now, both of these are examples of power functions because they consist of a coefficient, pi or 4/3 pi, multiplied by a variable r raised to a power. Now, a power function is a function that can be represented in the form f of x, which is equal to a constant k times x to the power of p, where k and p are real numbers and k is known as the coefficient.